Hello! Today we're going to have a look at the different differentiation you can be asked to do in the Use of Maths Calculus paper. There are three sorts of functions you're expected to be able to differentiate. The first is polynomials, and with polynomials that is anything with the form ax to the power n. And when I differentiate this, I times by the power and then I take one off the power. The key things to remember for this is if I have just like we have here 3x, that's really 3x to the power 1, so when I times by my power I'm going to get 3, because 1 times 3 is 3, and then I take 1 off the power and I get x to the power 0, and anything to the power 0 is just 1, so this just becomes 3. And if I have a constant on the end, well, this is really just 5x to the power 0, because that's 5 times 1. I differentiate this and I times by the power, well, I get 0 times, and it really doesn't matter what happens after that. 0 times anything is 0. So yes, I could write it as 0 times 5x to the minus 1, but the 0 is just going to make the whole thing 0. So when I differentiate this polynomial, I'm going to write dy by dx to show that I've differentiated it. Getting your notation right is very important. It's very important that I'm clear where I've differentiated. So x cubed, I times by my power, I take 1 off my power. 2x squared, I times by my power, I take 1 off my power. Minus 3x, I times by my power, take 1 off my power, and the plus 5 disappears. So that's the first sort of function we can be expected to differentiate. The next sort are logs and exponentials. If I differentiate e to the x, I get e to the x back. It's because e is a very, very special number. If I differentiate ln x, I get 1 over x. And finally, I can be expected to differentiate sine and cos. If I differentiate sine, I get cos. So again, I'm going to write dy by dx to show I've differentiated it, and I'll get cos x. And if I differentiate cos, I get minus sine x. Let's have a look at a couple of exam questions which have these in. I'm not going to have a look at the logs and exponentials differentiation in exam questions, because so far when that's come up, it's always come up in integration by parts or product rule. So there aren't any examples which I can quickly work through. But let's have a look at the polynomials and trigonometry. So the first one I've taken from the Calculus 2006 paper. Maria hits a ball while playing tennis. The vertical height of the ball, y meters above A, the point at which it was hit, is given by y equals 4t minus 5t squared. Find dy by dt, the vertical velocity of the ball, in meters per second. So all I need to do is I'm starting off with a polynomial. I differentiate my polynomial. So when I differentiate 4t, I just get 4. When I differentiate minus 5t squared, I get minus 10t. And then let's have a look at an example where we've got to use our trigonometry. I'm starting off with x equals 5,000 plus 1,500 cos t. I need to differentiate that. Well, just like with the polynomials, the constant's going to disappear. So I just need to worry about my 1,500 cos t. Well, cos differentiates to minus sine, so this is going to give me minus 1,500 sine t. So, as a quick summary, when I differentiate a polynomial, I times by the power, take 1 off the power. When I differentiate y equals e to the x, I get dy by dx equals e to the x. When I differentiate y equals ln x, I get dy by dx equals 1 over x. When I differentiate sine x, I get cos x. And when I differentiate cos x, I get minus sine x.